Good evening, viewers. This is Kasturi Day. Today, I'm going to discuss the properties of electrons and then the other discoveries, that is the positive particle, the positive charged particle which is present in the atom, that is the proton. We will discuss in this video. So, before I start, I will request you to please to subscribe my channel and ring the notification bell, that is, so that if, when as and when the new video is uploaded, you can get the notification. And if you are liking the videos, press the like button, share with your friends so that they can also do benefit from these videos. Okay. And don't forget to meditate before starting your day. So we will start with a meditation, short meditation for just 1 minute, and then we will start the video. Okay. So for meditation, please concentrate on a point of light. You can think a bulb to be the point of light. Switch on a bulb and think that to be the point of light which is reaching you. That light rays are reaching you, giving you energy. Concentrating on that point of light. Okay. Coming and going. Enjoyment, pleasant, you're fully charged now. You can do whatever you want. Express whatever job you're doing, studies, start your day. Full interest in this. Positive thought. Meditation segment. So, for that discussion, in my last video, I was discussing about the discovery of electrons, how was it discovered, and now I will start with the properties of electrons. So, electron, as we know, is a subatomic particle which has a negative charge, unit negative charge, and a mass of 1 by 1837 of hydrogen atoms. See, such a very negligible mass it has. Okay. So it is 1 by 1837 of hydrogen atoms mass is the mass of an electron. It is denoted by small e with a subscript of -1 and superscript of 0. Okay? And where that means 0 superscript means it represents the mass because it has negligible mass. So mass is represented by 0 here. Superscript is 0 and subscript is -1, which indicates the electrical charge of unit negative charge. Okay, here. So that's why it's denoted as E for electron and 0 as a superscript of mass, indicating the mass, and -1 as a subscript indicating the electrical charge, okay, which has a where it has a negative unit charge. Okay. Now, electrons from all sources are alike, having identical mass. If from all sources electrons, they have identical mass. Mass is same. Okay. They are the constituent part of the atom. Major part of the atom is one of the major part is electron. The mass of electron is negligible, which is equal to, I told you, it is 1 by 1837 or 9 of a hydrogen atom, and that is equal to 9.108 into 10 to the power -28 grams, or 9.108 to 10 to the power -31 kg. which is almost negligible. That's why this has been represented by a superscript of mass, representing the mass of 0. Okay. Now, hydrogen is an atom of the lowest mass. That's why hydrogen has been used. Okay, and also this electron mass is much lesser than that of hydrogen. Okay, and since the mass of hydrogen atom is 1 mu, it is said that the relative mass of an electron is also mu. Okay. Then the absolute mass of an electron is 9 into 10 to the power minus 28 grams. Its charge is 1 unit negative charge, and that is equal to minus 1.602 into 10 to the power minus 19 coulombs. Coulomb is the unit of charge. The electron is extremely small, which has a radius of less than 1 into 10 to the power 10 to the power minus 15 meters. Okay, the electron is very small. Okay, and it has a radius of less than 1 into 10 to the power minus 15 meters. So such a less radius it has. Okay, imagine how small it is. That its properties are independent of the gas in the discharge tube. I told you in my last discussion that electrons were discovered when the cathode rays emitted certain particles when gas was passed through inside a discharge tube. When the gas, the discharge tube was filled with gas and electric current was passed through in the discharge tube. In the last video, I told you. So that time the gas ionized, okay, and the cathode started emitting particles. Okay, and those particles were electrons, negatively charged particles. That was electrons. But the properties of this cathode ray particles, that is the properties of the electrons, they were independent of the gas which is used in the discharge tube. It does not depend whichever gas it is used. Okay. That is, they will have all the electrons, all the gases, all the electrons will have a negligible mass, negative charge, negative unit charge, okay? And the mass will be equal to 9.108 to the power minus 28 grams, or 9.108 into 10 to the power minus 31 kg, and the unit charge will be equal to 1.602 into 10 to the power minus 19 coulombs. And the radius of the electron of an electron will be 1.10 to the power minus 15 meters. So these properties will remain the same. So next will be so note that after this discovery of the electrons, okay, after the discovery of the electrons, it was found that the atoms are electrically neutral. So that means there must be some positive charge present in the atom which will neutralize the negative charge of the electrons. That is why the atom's charge is becoming neutral. So for that concept, that atoms are electrically neutral, that concept that led to the discovery of the protons. Now, hence, they must contain some particle that is positively charged in addition to the electrons. So, the total negative charge of the electrons becomes equal to the total negative charge of the, total positive charge, equal to the positive charge. Now, due to this realization, positively charged subatomic particles, that is protons, were discovered. Now, for that reason, for the discovery of the protons, a high voltage current was passed through a gas in the discharge tube, okay, where the electrical energy, when this high voltage current was passed, this electrical energy breaks up the atoms of the gas into negatively charged electrons and also positively charged protons. You know that it has ionized the gas, that is negatively charged electrons are discovered. Now it also breaks the gas atoms into positively charged protons. we move on to the discovery of the protons. So we found that that led to the discovery of the protons. Now it is who discovered the protons. The Goldstone was a scientist. He noticed another set of rays which are traveling in the opposite direction. From the cathode rays were emitted, which moved in one direction. Okay. And now another set of rays that moved in the opposite direction. Like if the cathode rays are moving in this way, the anode rays were moving in this way. Okay. Now, if this opposite direction, they move from anode to cathode. First, the electrons at cathode rays, they were moving from cathode to anode. Now they are moving from anode to cathode. Okay, the opposite direction. This was first noticed by Goldstone. Now he used a modified cathode ray tube with a perforated cathode. Okay. The cathode ray which was used by Thomson, J.J. Thomson, that was not perforated. Now here, Goldstone used a perforated cathode tube. Okay, a modified cathode tube was used by Goldstone. He observed a new type of rays produced from the anode, which passed through the holes of the perforated cathode. So some rays were emitted from the anode and it passed through the perforated cathode, it hit the holes. Okay, now what is it? These rays are called just behind the cathode effect. So these rays are called canal rays. Okay, these rays which are emitted from anode, which pass through the perforated cathodes, they are known as canal rays by him. That is, Goldstone named these rays as canal rays. Okay, as these rays pass through the holes or canals in the cathode, that's why he named them as canal rays. Later, these rays were known as positive rays or anode rays. Now, anode rays or positive rays consisted of positively charged particles, which are now known as protons. Clear? Now, the positive rays were affected by electric and as well as magnetic fields. So, electric and magnetic fields, they affected these positive rays in a direction opposite to the cathode rays. If the cathode rays move this way, then the anode rays will move this way. Okay. Thus, with the discovery of the positive particles, photon was initiated. Now, this is the tube which was used by Goldstone. This is the perforated cathode ray, and here we see the anode rays. Okay, this is the this one cathode rays. Okay, so this is the cathode and this is the anode. Now, anode, they emitted some rays which passed through these perforated cathode and started moving in this way. Okay. So this is the experiment which was done by Goldstone. Okay. With this modified discharge tube. High voltage current was used. Now, what are the properties of anode rays? Anode rays also travel in straight lines like the cathode rays. They consist of minute material particles producing mechanical effects. So they consist of minute material particles which has some mechanical effects, which produces some mechanical effects. Okay. They are made up of positively charged particles, and so they cause these mechanical motions as they have some positively charged particles. Okay. And these are minute materials, they have some positively charged particles, and therefore they produce some mechanical effects. The mechanical motion was produced by these particles. Okay, these positive rays are deflected both in the electric and as well as magnetic fields. So electrics, when there is an electric field, the positive rays, they move towards the negative plate. And if there is a magnetic field, they will move towards the south pole. In the direction opposite to the cathode rays. That means in the cathode rays, in case of cathode rays, when there is an electric field, as they are the negatively charged particles, they will move towards the If there is an electric field, they will move towards the a positive plate. Okay, and if there is a magnetic field, they will move towards the north pole. But in case of anode particles, positive rays, they will move towards the electric field. If in case of electric field, they will move to the negative plate, and in case of magnetic field, they will move towards the. These rays are named as protons. Now they cause some heating effect and they have some kinetic energy. Okay, so anode rays, they have some heating effect, they have some mechanical effects, they have some kinetic energy. They will move in the opposite direction as that of the cathode to that of the cathode rays. Okay, and they are positively charged particles. Even they produce some fluorescence when they fall on some zinc sulfide screen. If they are allowed to fall on zinc sulfide screen, they will produce some fluorescence. Now, the E by M ratio, that is electron by mass ratio of the particles in the anode rays, is not constant and depends on the nature of the gas taken in the discharge tube. This is unlike what? Unlike the cathode rays. Because in cathode rays, the E by M ratio does not depend on the nature of the gas. The mass does not depend on the nature of the gas. The electron does not depend, the electric charge does not depend on the mass, on the nature of the gas in the discharge tube. But here, it depends on the nature of the gas in the discharge tube. Its value is much less than that of an electron. This E by M ratio is much lesser than that of the electron and is maximum when hydrogen is taken in the discharge tube. Okay, if hydrogen is taken in the discharge tube and the electric current is passed, then E by M ratio for a proton will be maximum. Clear? Now, properties of protons. What are the properties of protons? As I told you, they are the subatomic particles which has a mass of 1 AMU and which is equal to hydrogen atom and has a unit positive charge. In case of electrons, they are also subatomic particles, but they have a mass of 1 by 1837 of mass of hydrogen atom. But here it has a mass of 1 AMU, which is equal to the mass of hydrogen atom. Okay, and has a unit positive charge. It is denoted by capital P with a subscript of +1 and superscript of 1. Okay, the electron had a subscript of -1 and superscript of 0. Okay, so superscript of 1 means it has a mass of 1 AMU. And the subscript of +1 means it has a unit positive charge. 1 unit positive charge. It is formed by the loss of electron from a hydrogen atom. How is a proton formed? It is formed by a loss of electron from a hydrogen atom. So if one atom of hydrogen loses 1 electron, it becomes H+. That is, the proton is formed. Okay. The value of unit positive charge of proton is equal to 1.602 into 10 to the power -19 coulombs. Okay. And mass of proton is equal to mass of hydrogen, that is equal to 1 AMU, that is 1837 times the mass of an electron. That is equal to 1.672 into 10 to the power -24 grams. The proton resides in the central part of the atom, that is, it is in the nucleus. And electrons will be revolving around the nucleus, like the planets. And then proton is present in the center of the nucleus, that is center of the atom, that is in the nucleus, like it is present in the sun, inside the sun. Now we come to the J.J. Thomson's plum pudding model. See, after the discovery of the electrons and protons, this model was proposed by J.J. Thomson in 1897. That means two subatomic particles were discovered. That is one electron and one proton. Okay, second is proton. Now, that means one negative charge and one positive charge was discovered. So that means after this discovery, J.J. Thomson, he proposed a model, okay, that is plum pudding model, which was discovered in 1897. Okay, he proposed this model in 1897. According to this model, an atom consists of a positively charged sphere with electrons embedded in it. It has a positively charged sphere where electrons were embedded in it. Okay. An atom as a whole is electrically neutral because the negative charge and the positive charge, they are equal in magnitude. That means total amount of negative charge is equal to total number of positive charge. That's why it's electrically neutral. The mass of an atom is considered to be uniformly distributed. And this plum pudding model, it represented the pudding where there is some this one. Think that this pudding is positively charged sphere, and the chocolate chips that were embedded in the pudding, these chips were negatively charged electrons. Okay, that's why it represented the plum pudding model. Now, the discovery of nucleus. It was discovered in 1911. This nucleus was discovered in 1911. Lord Rutherford, he was a New Zealand scientist. He, along with Marsden and Geiger, they discovered this. Three of them, they discovered in 1911 the nucleus. How did they discover? They bombarded a thin gold sheet. This gold sheet was 100 nanometer thickness, and this sheet was bombarded with some alpha particles which were emitted by radium. The radium is a radioactive metal, so it emitted some alpha particles, and these alpha particles bombarded a thin gold sheet of 100 nanometer thickness, which led to the discovery of this nucleus. Now, this experiment was conducted to study the deflection produced in the trajectory of alpha particles after interaction with a thin sheet of gold. Okay. Now, they counted the number of sparks. They then counted the number of sparks by these alpha particles, which were produced by these alpha particles on the zinc sulfate screen, which detected the deflection. Okay, so these alpha particles, which were emitted by radium, they hit that thin gold sheet. They bombarded that thin sheet. Then, after each bombardment, what happened? The sparks were emitted, and they hit the zinc sulfate screen. Okay, and the number of sparks that produced as they hit the zinc sulfate screen, that showed the deflections of the alpha particles. Okay. From this, they concluded that almost all the atomic matter was concentrated in the tiny volume which is situated at the atomic center. Almost all the atomic matter is concentrated in the center of the atom. Okay. Now, according to his observations, major fractions of alpha particles, they pass through the foil undeflected. Major fraction of the alpha particles, they pass through the foil undeflected. A few alpha particles were scattered by very small angles. So, major alpha particles that just passed through this, through the foil without deflection. Okay, few particles they scattered by very small angles. That is, slight deflection was there. And very small number of particles, they deflected back by 180 degrees or deflected by large angles. They deflected. Okay. So this was seen by Lord Rutherford. So this is the picture you can see. Atoms of the metal foil. See, this is the gold foil, tin foil, and these alpha particles, they started bombarding this foil. And what happened? Maximum of them, majority of them, they passed through without deflection. Some deflected slightly, and very few, they deflected by 180. Okay. So these were the this was the experiment which was done. Okay, this is the gold leaf here. It was used. So, according to Rutherford's atomic model, from the observations of Rutherford's alpha particle scattering experiment, he suggested a model which was known as Rutherford's atomic model. Now, it has been noted that heavy metals like platinum will give the same observations with alpha particles as which is shown by gold foil. But nuclei of light metals, okay, like lithium, if we use lithium in place of platinum or gold, instead of heavy metals, so then we will see that they may show their fast-moving alpha particles push the light nucleus aside and may not be deflected back. So they will push the nucleus to one side and they will start moving. It passes through the atom without deflecting, back. So this happens in case of only light metals. But in heavy metals, the alpha particles will show the same character as it has shown in the whole. Now, what are the postulates of the atomic model which we see? So, the postulates are, first postulate is an atom is composed of positively charged particles. Majority of the mass of an atom was concentrated in a very small region which is known as the nucleus of an atom. The nucleus is the densest part of the atom. The nucleus is electrically positive as the positively charged alpha particles approaching the nucleus gets deflected, providing the nucleus contains the protons. An atom's nucleus is surrounded by negatively charged particles known as electrons, which revolve around the nucleus in circular paths or orbits or shells with very high speed. The force of attraction between the negatively charged electrons and positively charged nucleus is counterbalanced by the centrifugal force acquired by the revolving electrons. This is a strong electrostatic force. Okay, this counterbalance is this centrifugal force is a very strong electrostatic force of attraction that holds the nucleus and the electrons together. Okay. So there are a few more postulates which are present in the atomic models. Okay, I think I'll discuss this postulates in my next video. Just I read once and then I will explain you in my next video. That is, an atom has no net charge because the total negative charge is equal to the total positive charge. It's counterbalanced. Okay, so for the size of the nucleus of an atom is very small in comparison to the total size of the atom. This is proved by the fact that most of the alpha particles pass through the straight line through the gold foil. Besides these atoms, a large empty space is also theirs. Okay, extra nuclear space, you can say. That's why through the metal foil, the majority of the alpha particles, they pass through it without deflecting. Then his atomic structure, this Rutherford's atomic structure is similar to that of the solar system. Okay, the sun is at the center, the planets revolving around it. Like that, the nucleus is at the center, and the electrons are moving around, revolving around as in the orbits of shells. Okay, so this is the picture you can see. There are the Rutherford's atomic model. This is model which Rutherford used. This is the nucleus, and these are the electrons revolving like that. The solar system is there. Sun is in the center, and the planets are revolving around. So I will discuss with you this postulates in my next video. From this postulates, I'll start the discussion in my next video. So till then, please go through the video. If you have any doubts, please do write in the comment box. You can also share in my email ID, that is kasturi74@gmail.com. And please do subscribe my channel, ring the notification bell. And also, if you are liking the videos, press the like button, share with your friends so that they can also be benefited from these videos. And don't forget to start your day with meditation. Okay, you will get benefit. I am sure you will get a good benefit from those meditations. Okay, and if you want more meditation knowledge, I can give you. If you want it, please write in the comment box. I can share with you some videos. Okay, which will help you in your increasing your concentration power. So thank you for watching and have a good day.